Okay, I think we can get started. Hello, everybody. My name is Ravi Nori. I'm a software engineer in the Rev Engineering Group at Red Hat. Today, I'll be presenting an overview of the Command Coordinator and the Command Executor frameworks. This is the agenda for today's talk. I'll be talking about the motivation, the general design, who should use it, how to use it, and the future work to enhance the framework. So the motivation behind the command coordinator changes is to reduce the async task manager dependency from the backend code and to also provide command persistence for non-storage related operations. And the motivation behind the command executor framework is to enable execution of long duration operations not related to storage, and to also provide better scaling by limiting the number of threads in which the commands are executed. So there's still some planned features to improve the command executor framework, which I will talk about at the end of the presentation. So this slide gives you a high-level design overview of the framework. The framework has a separate thread pool in which commands are executed. The size of the thread pool can be configured using one of the options in VDC options table in the database. The name of the option is Command Coordinator Thread Pool Size. The default value that is set for the thread pool size is 10, but it can always be increased or decreased depending on the need, but it requires a server restart. So commands that are executed using the command executor framework can provide their own command callback implementation. So what this does is it registers the command with the command executor, and the command executor invokes the methods in the command callback at various lifecycle events in the command. So currently there are 4 different methods in the command callback: executed, do polling, on succeeded, and on failed. The executed method is invoked when the execute method of the command has completed execution. The do polling method is invoked by a quads job. This is where the command can actually, the command callback can actually run custom logic to determine the status of the command. Once the status has been determined, the command can update its status with the command coordinator, and the on succeeded and on failed methods are invoked. Okay, so the command entities are always persisted in the database. A command entity contains all the information that's needed to rebuild a command on a server restart. So if the engine is restarted, the command can be reconstructed from the command entities saved in the database. So the command entities has the parameters, the status, the result of command execution. All this is persisted, and the changes made to the parameters are persisted in the database. Command coordinator exposes methods to persist and retrieve command status. The results of the execution. The command executor exposes methods to run commands asynchronously. So diving a little bit deeper, okay, I'm getting a lot of pings. People can see, some people cannot see. This is the first time we are using Google Hangout, so please bear with me. So the general design, we are looking at threads, the threads that are in the framework. So there are 3 different threads at play here. One is the calling thread. The calling thread is a thread in which the command is persisted and registered with the framework. And there's a second thread, which is the thread pool, in which the command is actually executed. And the third thread is the quads job that invokes the different methods on the command callback, that the do polling, executed, on failed, and on succeeded. So it is a good practice to keep the do polling and everything as short as possible, because it's running in a separate thread. So here is a flow of a sequence of flows that happens when a command persists itself with a command coordinator. So the command is calling persist command with enabled callback. So it is the command coordinator first persists the command into the command entities table in the database. And since a callback is enabled, the command gets the command callback from the command. So the command actually has to provide a callback implementation. We will look at examples of how to do it, but for now it's enough to know that the command is providing the command callback. Once the callback is retrieved from the command, it is registered with the framework, and the quads job picks this particular command callback up and invokes a do polling method. The command callback can, at this stage, execute its custom logic to actually perform, to look at the status of the command. And once the status of the command has been determined as either succeeded or failed, the callback updates the status of the command with the command coordinator. This updated command status is persisted in the database along with all the other information. And the on succeeded or on failed method is called. This is just a sequence of things that are going on. Diving a little bit deeper into what happens inside the command coordinator framework and the command executor framework. Say here we have a command that submits another command for execution using the command coordinator's execute async command method. Now, this particular command is persisted in the database, and if callback is enabled, we register it with the command executor framework, and then the command is submitted in to the thread pool for execution. So the persisting and checking for enable callback and registering the command takes place on the calling thread. And after the command is submitted to the thread pool for execution, the command executes in its own thread pool. And then the quads job picks up this particular command that has been registered and checks for each command that has been registered if the callback has been enabled, has been notified. If the callback has been notified, the command has reached the end of its life. Otherwise, we check if it's failed or succeeded. And depending on whether it's failed or succeeded, the on failed or on succeeded method in the command callback is invoked, and we update that the command has been notified, and we reach the end of the command's life. If the command is still active, we wait until the command's execute command has been executed. So the new framework introduces something in command base. So once the command has completed execution, the status of the command, a flag is set in the command saying that it's executed. So the command entity knows the command is executed. So once it's executed, we invoke the do polling method on the command, giving the chance for the command callback to execute the custom logic to determine the status of the command. And the entire thing is repeated until there are no more commands to manage. So let's look at who should use these commands, this framework. So say you have a command, all that you need is a simple logging of the command execution. So all that you need is every time the command is executed, you want an entry in the database saying that the command is executed. So if that's all you need, you can use this framework. It's a very simple use case. And the second use case is, say you want to determine if the execute method is completed. So some of the times when we try to execute a command, it fails, and the end with failure method is invoked. In end with failure, you would like to know if the execute method of the command completed without any issues. So if an exception is thrown, the execute flag is not set. If no exception is thrown and the execute method of the command was completed without any exceptions, the execute flag is set on the command. So now you know that the command has completed execution. We need to do some cleanups or any other logic pertaining to the command. And sometimes we want to run long-running commands like removing an image. We just want to submit it and forget it. We don't care about what the return value of the command is, whether it succeeded or failed. If there are commands like this that you'd like to perform and you don't want to wait for them, you can submit it to the thread pool for execution using the command coordinator. And you can also run long-running asynchronous tasks, both storage and non-storage related, and determine the command status using custom code by providing a command callback. So we will be seeing examples of all these as we move on to the next slides. So how do we use the logging feature? So this shows you an example of how to just perform logging. So I have modified the execute command method, and I'm invoking persist command. So that's all that is needed. So the command actually is persisted in the database as a command entity in the command entities table. And at the end of the execute command, I'm setting the status based on whether it succeeded or failed. So every time this command is executed, we are going to see an entry in the database. This is a very, very simple use case, but it gets us started to go on and build on this particular example. So the second example here shows you in end with failure. So this particular command has failed, and in end with failure, we would like to determine if the command failed because of a server restart or some other issue. So if the command is executed without any exceptions, it means there was some other issue and we need to perform the logic to do a cleanup. If the command failed because the execute method did not get a chance to complete, so in that case, we may not have to do a cleanup. So end with failure can actually retrieve the command execution status from command coordinator and do the logic according to what it needs. So one more thing that's saved in the database is the VDC return value. So most of the commands already do this. We set the action return value in the return value of the command. So we say get return value, set action return value. And if this is done, the return value of the command is automatically saved in the database at the end of the execute method. So moving on, command status. So what are the different command statuses and what each one means? So when a command is constructed, it's in not started state. And when the command is executing, the execute method has been invoked, it's an active state. After the execute method is completed, a flag is set indicating the command is executed. Failed and succeeded, I don't think it needs explanation. Failed, restarted. So when the engine is restarted and we find that there are some commands whose execute method did not complete, in that case, we set the status to fail restarted, and actually we fail the command. And unknown is used in cases where you try to retrieve the command status, but the command is not found in the database. So we set the status to unknown. So this shows us an example of submit and forget command. So in this case, this particular command wants to execute removal of an image, but it doesn't want to wait for the return value of the command. So in this case, all that the command needs to do is provide the VDC action type and the parameters and execute the async command using the command coordinator. So this moves into the real command executor framework with command callbacks. So how can a command provide a custom command callback? So this command is trying to register itself to the command executor to be managed by the command executor. So the persist command here is a little bit different than what we used earlier. We are passing a Boolean value indicating that this particular command needs to be managed by the command executor. And then we override a method from command base, the get callback method, and provide our own custom callback implementation. So when this is registered with the command executor, it retrieves the custom callback, and all the lifecycle methods will be invoked on the custom callback. So how does the custom callback look? The command callback is an abstract class, and all the methods have a default empty implementation. So the custom callback needs to only override those methods that it needs custom logic in. So in this case, most of the methods are empty, so I need not have overridden them. Only thing that's doing something here is the do polling method. I'll be talking about child command IDs later on, but for now, all that we need is command ID. So this particular command did not have any child commands. Now we can perform custom logic in this do polling to either look at the database or some other location to determine the status of the command. And if the status of the command has changed to either succeeded or failed, the do polling method updates the command status with the command coordinator, and the rest of the logic is taken care of by the command coordinator framework. The on failed, on succeeded is called. So this looks at parent command with child commands. So in this case, a parent command has a set of child commands that it wants to execute. So in the execute method, we call persist command, and again we pass a Boolean value indicating that this particular command needs to be persisted and managed by the command executor framework. It's important to call persist command with a true before actually executing the child commands, because command executor creates a hierarchy of parent to child commands. So the parent, it's good to have the parent before the child so that we get the hierarchy right. And this parent command has also overridden get callback method with its own implementation of custom callback. We'll be looking at how this one looks in the next slide. So the parent command, after it persists and registers itself with the command executor framework, it loops through the set of child commands it needs to execute and executes the async command, passing the VDC action type and the parameters for the command. This is how the parent command callback looks. The do polling method is invoked by quads in a separate thread. So here we pass the list of child command IDs. So the parent command can look at the status of each of the child commands and determine its own status. And if it is succeeded or failed, it updates the status of itself with the command coordinator. And in the end, it's an optional thing. You can just leave the commands in the database if you want to have it as for some kind of a logging. But it's optional to call a remove all commands in hierarchy passing the parent command ID. This will remove all the commands for the parent command and the child commands. That's an entire hierarchy. So we have discussed a lot of things for the future of this particular framework. Many things popped up. One of the most interesting things was event-driven callbacks. Currently, we are doing do polling over and over again in order to determine if a command has succeeded or not. This could cause considerable overhead if there are lots of commands. So we are thinking of some kind of an event-driven approach where the callback is notified by an event if it has succeeded. So we don't have to invoke do polling over and over again. And there have been some ideas around submitting a command for execution. And if it fails, we retry the execution of the command n number of times before we give up. And there's also talk about periodic execution of the command so that the command gets executed at regular intervals of time. And we have two different frameworks now. If you remember, we have an async task manager framework, which is used for storage-related operations. And we have the command executor framework, which is a new framework where you can execute non-storage related operations. But there's nothing stopping us from merging these two into one and having just the command executor framework and completely getting rid of the async task manager framework. So this way, we have only one framework to deal with. So we could be working on that. So that's all I had. If you have any questions, please email me or contact me on IRC. Let me just see if we have